So, hello friends, and welcome to the second lecture of Higher Engineering Mathematics. In the first lecture, we have just brushed up upon what is the basics of differential equations and what are its various applications, how is it important in life, and all the other things. Now we will actually dive into the details of differential equations and how can it be classified and many other interesting things. So, what exactly again is a differential equation? It is an equation which has got derivatives of a variable. So, for example, you could simply have y plus dy by dx plus d2y by dx square plus dqy by dx cube is equal to 0. Okay, this is an example of a differential equation. Why an example of a differential equation? Because it has got derivatives of something. Now let's dive into this particular term into a lot of detail. Now the normal term over here is y. Okay, the normal term over here is y. Now this y variable over here is a dependent variable. It's not independent, it is a dependent variable. Now what do you mean by dependent variable? It means that it cannot be defined or it cannot be understood on its own. It needs the help of someone else. It's like it's standing on crutches basically, and if you take off its crutches, then the variable, then the person will fall. In the same manner, if you strip it off by its independent variable, then it loses a lot of its value. So in this way, y is a dependent variable. Now what will happen when you strip this variable once, which means what will happen when you take its derivative once? So when you take its derivative once, then what will happen? This y will be changed. It will be changed to what? It will be changed to dy by dx. Now as soon as I've written we take a derivative, I should have been more specific, and by more specific I mean to say derivative with respect to what? That is the question. Derivative with respect to what? Fine. Now just imagine a very small example over here. Okay, let's say your mom has given you some instructions. Fine, your mom has given you an instruction to go and chop a vegetable from the fridge. Now do you go and chop the vegetable directly? No. You ask her, what vegetable do I have to chop? Then she will answer that you have to chop probably a capsicum or you have to chop an onion. Depending on that, you will decide which vegetable to choose and which vegetable to chop. That is exactly what is happening over here. When I tell you to obtain the derivative of a variable, then your question should be that derivative is supposed to be obtained with respect to what? The answer to that itself is you have to obtain the derivative with respect to x. With respect to x. Now if you just try to compare the sentence, if you just try to understand the sentence that I've written, you have to obtain the derivative of y with respect to x. So who has got respect over here? With respect to x. So who is independent over here? This x variable is definitely an independent variable. Understanding this is very important. The concept of a dependent variable and an independent variable. Over here, what will happen in this sentence? If you strip off this sentence from x, then what will happen? You have to obtain the derivative of y, but you don't know with respect to what, so you cannot move ahead. In the same manner, if I remove y, then you have to obtain the derivative of something with respect to x. You already know who is the independent variable over here. So this independent variable always holds a very important value. A simple trick to understand is these pair of words with respect to. See who is getting the respect. You have to obtain the derivative of y with respect to x. That gives x a very huge privilege. That privilege is x is an independent variable. Fine. So stories apart. How do you represent this line? Derivative of y with respect to x. This line is represented by dy by dx. Over here you have stripped off y, which is you've taken the derivative of this y, but that derivative is with respect to x. Fine. So when you change this independent variable, then what happens? The derivative also changes. We will see that in subsequent lectures, but this part is very important. This is the independent variable, while this is your dependent variable. Fine. Then you're not satisfied by one single chop. Okay, you have chopped this y vegetable once. You're not satisfied with that one single chop. Then what do? You chop it again, correct? That is what we will exactly be doing over here. You have stripped off this variable once. You're not happy with the result. Then what will you do? You will take its derivative again. Again, I will take its derivative with respect to x. Then what will happen? This will now change. This was the main variable. You have taken its derivative once. This is the answer. You will take its derivative again. Then you will be getting d2y by dx square. See, that is the difference between a dependent variable and an independent variable. Okay, then what will happen? You're not still satisfied with the answer that you've got. You're not still satisfied with the result that you've got. Then what will you do? You will take its derivative again to get the answer dqy upon dx cube. So now see carefully. In this whole thing, you have taken the derivative once over here, twice over here, thrice over here. So that itself determines how, now by directly looking at these variables. So now I hope you have understood this chain. Now by directly looking at this variable, can you try to answer how many times the derivative is taken? For example, if I directly tell you that in the term of d4y upon dx raised to 4, if I directly give you this term, then can you answer how many times the derivative has been taken? The answer is 4. So how did you reach to this answer 4? So this is how this thing works. You had a normal variable y. You took its derivative once to get dy by dx. Then you take its derivative again to get d2y by dx square. You take its derivative again to get d cube y upon dx cube, and then you take its derivative once again in order to get d4y upon dx raised to 4. So by directly giving you one derivative, you can now answer how many times the derivative has been taken. Understanding this also is important. So if you're trying to find a solution to some kind of an equation and you directly have some larger term like d raised to 5, d raised to 6, then what does that mean? The derivative is taken 5 times or 6 times, whatever is the number that is present over here. Fine. I hope you understand that. You have a normal variable y, you take its derivative once, you get dy by dx. You take its derivative again to get d2y by dx square. You take its derivative once more to get d cube y by dx cube. So now following this chain, what will be the last term that you could possibly take over here? The last term could be dn y upon dx raised to n. That is going to be your last term that you could take the derivative of. Now see, what is this number called as? This number is called as the order of the derivative. It is called as the order of the derivative. And what does it mean? It is the highest number of times It is the highest number of times the derivative is taken. It is the highest number of times the derivative is taken. That is the order of that equation. That is the order of derivative, or it is also called as the order of differentiation. That particular term is called as the order, the highest times the derivative is taken. Fine. So now okay, now see, for this given equation, let's try to find out what is the order. What is the order in this particular equation. What is the order? The highest number of times the derivative is taken. Over here, how many times is the derivative taken? 0. Over here, how many times is the derivative taken? 1. If you see, the exponent over here is 1. Then over here, how many times is the derivative taken? 2 times. Over here, how many times the derivative is taken? 3 times. So what is the highest number of order that you got? 3. That is the order of an equation. So to move further ahead, let's try to solve this equation. Y square plus y d2y upon dx square equal to 0. Over here, what is the order? This is the answer for this. Over here, what is the order? Now see carefully. Over here, how many times the derivative is taken? 0. Over here, it is directly taken twice. Do you have any more term where you've taken more number of times of derivatives? No. So the highest order of derivative over here is 2. Done. That was order. In the next lecture, we will definitely be seeing what is degree, and we will also solve some simple examples on this. So see you soon.